11.5 mathematical induction. It starts with a question, I guess. It says, consider Sn equals 1 plus 2 plus 3 plus ... plus n. Is it true that Sn equals n times n plus 1 over 2? This is kind of the question, the recurring kind of question that we're going to be asking and answering in this lesson, mathematical induction. Basically, we're proving things. We're doing proofs, okay? So it's kind of difficult to think about. You can kind of play around with the numbers, and you can look at S1. S1 is the sum of the first term. That's just 1. Let's look at S1 over here. If we plugged in 1, we'd have 1 times 1 plus 1 over 2. That's going to end up being 2 over 2, which is 1. All right, so S1 is 1 no matter which way you slice it, okay? So maybe I have an intuition or a feeling here. Look at S2. S2 would be 1 plus 2 equals 3. Or over here, if I do S2, basically I'm just plugging in 2. I would have 2 times 2 plus 1 is 3 over 2, that's going to equal 3, okay? So whether I look at the statement on the left or the statement on the right, I'm going to get 3. Let's do one more. Let's see S3. The sum of the first 3 terms, 1 plus 2 plus 3, is 6, right? Those 3 adds up to 6. If I look at the formula S3, I plug in 3, I'm going to have 3 times 4 over 2. That's 12 over 2, which is 6. Okay, so my gut feeling is that, yes, this is true. Is it true that? I feel like it's going to be true no matter what number I plug in. But unfortunately, that's not thorough enough to serve as a proof. I've only really proven it for n equals 1, 2, and 3. I need to prove it for all of the n's. Okay? So that's where this concept of mathematical induction comes in. All right. It says let some statement be Sn be a statement concerning the positive integer n. Suppose that 1 S1 is true, 2 for any positive integer k is less than or equal n. If Sk is true, then Sk plus 1 is also true. Then Sn is true for every positive integer value of n. Okay. That's really complicated and confusing. I get it. All right, so you might want to read that again and again and again. But what I want you to think about is dominoes, okay? You ever set up like dominoes, and there's one here and 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 one bunch of dominoes, okay? And you're going to try and knock them down. You set them up and you knock them down. And so this proof, this mathematical induction, is kind of like knocking down dominoes. The first step is just proving that we can knock down the first domino, okay? We're going to knock down that first domino. And then the second step, this is the one that's interesting and where the math happens, just says that off in the future somewhere, let's say we knocked down this domino, we need to show that it knocks down the next one, k plus 1, all right? So it's kind of like knocking down dominoes. And if you think about it, if we can just say there's some domino off in the future and we knock that one down and then that knocks the next one down, that's going to be enough to prove that all of the dominoes fall down. All right? So it's 2 steps basically. Show that we knock down the first domino and then show that there's some domino in the future that we knock down that will knock down the next one, k and k plus 1. How to prove by mathematical induction? You're going to have those 2 steps, okay? So step 1 is that first domino. It says verify the statement is true for the first item. So you're going to show S1 is true. Usually by plugging in n equals 1. That's usually what you're going to do. Step 2 is going to be the hard step. Okay? Show that Sk implies Sk plus 1. Generally, what's going to happen there is you're going to write the equation or the statement with k instead of n. And k is supposed to stand for some number. K is just some number, and some number off in the future. I don't know what it is. It doesn't really matter. But we're just going to assume that it's true for some number k. And then we have to show that leads to a true statement for k plus 1. K plus 1 being the next number or the next domino, if you will.